Okay, when you start the software microcap, you should see something like this. If you don't see so many things over here as I do, problem is probably here. You can select what kind of things you can see and what kind of things you can't see. So in case you don't have so many menus here, you can select from here, but let's leave it like this. Okay, I'm trying to analyze my first op-amp circuit in a way that I first select my operational amplifier and I use the analog library component because these are more realistic than those analog primitives component, which are more or less ideal. So I'm picking up the one that we do have in the lab. I think it's LM741, which we do have in the lab, so I can drag it with my mouse wherever I want to. Probably I place it over here. And the operational amplifier is not working like that. It is an active component. It means that it needs supply voltages. Without those, it cannot work. How do I add it? Select this arrow, go back to this component and double click it. And you can see that the model is selected to be LM741. Just click OK. And you should see that op-amp power supply is added. It is doing it automatically, so they are right and they are okay. Just accept it. And it doesn't work just like that. I have to add some components. I can pick those up from here too, but for resistors there's quite easy menu over here. By clicking at that one, I get a resistor. I can put it over here and the value can be, let's say, 10 kilos. K means kilo, even though it's big one, it should be, put the small one as it is like that, and I can put another one over here and let's change that one to be 1K. Okay, and then I have to make my circuit. I can connect it with wire, so wire can be over there. And I make the connections. And ground is over here. These Americans, they have a different ground symbol that we do. Only one line is enough for us, but let's keep it like that. And I am picking up a certain DC power source or voltage source. You can get it from here and connect it to my ground. Ground has to be there always. If you don't add ground anywhere, this program doesn't know which kind of voltages it should calculate. I mean, they don't know the zero level, but when you add the ground, then you're telling the software that this is your zero level. Minus 15 is absolutely too much for my circuit. Instead, I put 1 volt and I connect that also to my circuit like this. If I want to know what is happening in here, I can analyze it, and for this purpose dynamic DC is good enough. Temperature 27, just fine, so I accept it. That's not in the best possible place, so I move it a little bit, and you can see that according to this analysis I have 1 volt here. Well, it's logical, there's 1 volt. Over here is almost 1 volt. When we are dealing with these operational amplifiers, we are normally assuming that in both of these input nodes we do have exact the same value. As you can see that it's not exactly the same. There is a small difference, but we normally neglect it. So we have 1 volt here, we expect there to be exactly 1 volt, even though it's not exactly like that, but we can live with that one. And the amplification factor, this connection is 11. So when I have 1 volt here, the output should be 11, and you can see it's almost, there are some, well, small differences, but whenever you are simulating real components, you should accept some kind of differences for those calculations that you are doing. with those ideal models that we normally have in our textbooks. And if I want to know what kind of currents I have here, they are over here. So normally I assume that operational amplifier is not taking any current, but as you can see, that's not exactly true. That's taking 70 nanoamps, but 70 nanoamps is almost nothing, and we can normally forget it. And here, according to Ohm's law, if we have about 1 volt here, 1 kilo ohm, it should be 1 milliamp as it is. And the same current over here, and means 10 volts over this one, so we have 11 here. So that was an easy and short way to make a first operational amplifier circuit simulation.